Hello guys, today we are going to do this integral question and evaluate the integral from 0 to infinity of inverse tangent of square root of x divided by x squared plus 1. And we are going to use two formulas. One is arctan a plus b is equal to this thing, and then the integral of this thing is equal to pi over 2 times root 2 times pi over 2 times root 2 times a squared plus root 2a plus 1. So here, how can we start though? Let me just write down the original question first. So the original question is integral of arctan square root of x over x squared plus 1 from 0 to infinity. Here, I'm going to use the Feynman technique. Let I of a is equal to our inverse tangent of a times square root of x divided by x squared plus 1 dx. And then we are going to differentiate both sides. We get I prime of a is equal to integral of, and then from 0 to infinity, and then 1 over x squared plus 1 is a constant. Put it in front. And then we are going to differentiate this. In our A row, when you are going to differentiate R10, you are going to do 1 over this square, which is a squared times x. And then, because of the chain, we are going to multiply by square root of x here in our A row. So, we are going to get integral like this. Integral from 0 to infinity, and the square root of x over parentheses x squared plus 1 times parentheses 1 plus a squared x. And here, we have a square root of x. We are going to use our substitution here. Let u is equal to square root of x. And then square both sides, you get u squared is equal to x. And then differentiate both sides, you get 2u du is equal to dx. So for dx, which is equal to 2 du, put it outside the integral, the 2, because it's a constant. Put 0 into square root of x, you get square root of 0, which is 0. Put infinity, square root of infinity, still infinity. And then we get a u here. This u times this u divided by we know that x is equal to u squared, so x squared is equal to u power 4. So this is just u power 4 plus 1 times 1 plus a squared. And then our x, which is our u squared, du. And look at this and this, they are really similar, right? Things we are going to do, just follow the other order. U squared over, this is a squared, but we are in the u row now, so when it's like this. So compared to these two integral, you can this integral is pretty much just the same as this. So we can use the result as this. So this is just equal to pi over 2 times root 2 pi over this, and then times a squared plus root 2a plus 1. 2 and 2 cancel out, so you are going to get I prime of a is equal to pi over square root of 2 times a squared plus square root of a plus 1 is equal to this. So I prime of a is equal to this. And then we are going to integrate back. Look at this, the a is equal to 1. When you put a is equal to 1, which is just the integral we are going to find. So we are going to integrate this from 0 to 1 dA. From 0 to 1 dA. So you get this is I of 1 minus I of 0. And then this is pi over square root of 2. Put it outside the integral. Like this. And then a squared plus 1 dA. So I'm going to figure out what's I1. Put 1 into it, which is just our integral we are going to find. Integral from 0 to infinity, arctan of square root of x over x squared plus 1. What is I0? Put 0 into it. Inverse tangent 0, which is equal to 0. So far, you are going to minus 0. Remember, I of 0 is not always gonna be 0. Remember, you need to put it back to our I of 0. So you can also don't use the integrating back method. You can get a form of I of a. Just I of a is equal to something. And here's the deal. I forget to write a dx. Let me put it on the top. Put it on the top because I don't have any space here. And then, so I'm going to evaluate this integral and then put down the result here. This integral, let me just solve it. Integral from 0 to 1. 1 over a squared plus square root of a plus 1 dA. Here, I'm going to use the computing the square method. So what this says, a squared plus root 2a. How to compute the square? Look at the coefficients of square root coefficients of a. The coefficients, take a half of it, which is square root of 2, half of which is square root of 2 divided by 2, which is 1 over square root of 2. And square that. But remember to minus is bad because it will change the result if you don't minus this. 1 over square root of 2 square dA. So this one you are going to get a plus 1 over square root of 2 square. And then here 1 over 2. Pretty much you get 1 over 2 here. So you can get plus 1 over 2 here dA. So do we need to do that? Do we need to multiply by 2 on both the denominator and numerator? No need, because we are going to use the formula. A plus 1 over square root of 2 square plus 1 over square root of 2 and then square that. Okay? This is also 1 over square root of 2. This is just a coincidence, you know. This is 1 over square root of 2. This also gonna get square root of 2 here as 1 over square root of 2 as well. So use our formula, integral 1 over x squared plus a squared dx. A is a constant here, and a cannot be equal to 0 here. This is equal to 1 over a times inverse tangent of x over a plus c, like that. But this is our indefinite integral, so we can ignore the ignore the c here. So if you let u is equal to this, du will be equal to this dA. So don't worry, just use a formula. 1 over this 1 over square root of 2, which is square root of 2, times inverse tangent of our, and then divided by 1 over square root of 2. So you pretty much just get square root of 2 times this. So you can get square root of 2 times this. You can get square root of 2a plus 1. And then evaluate from 0 to 1. You can get square root of 2 times inverse tangent of square root of 2 plus 1. And then minus our square root of 2 times inverse tangent of, put 0 into it, you get 1. So what we will get here? So we are going to factor out the square root of 2 here. And then what is inverse tangent of square root of 2 plus 1? This is kind of hard, right? No problem. We are going to use the formula given. Arctan inverse tangent, which is the same as inverse tangent. Inverse tangent of a plus b is equal to this. So we are going to use this. Inverse tangent of square root of 2 plus 1, which is equal to 1/2 times square root inverse tangent of 2 times our square root of 2. Our a, consider our a is just our square root of 2, and divided by 1 minus square root of 2 square, which is 2, and then plus 1 square, which is 1, and then plus 1 over inverse tangent of our, this time is b, b, which is 2 times 1. You can get 2 times 1, right? 2 times our b, which is this, which is 2, divided by 1 plus a square, which is root 2 square, which is 2, and then you are going to subtract 1 square, which is 1. So what are we gonna get? So you are going to get something like this is 1 plus 1 is 2. 2 minus 2 is our 0. 1 divided by 0. This is, we cannot say infinity, but we are going to get error here. But consider this a limit. Consider 1 over 0 is infinity here. In arctan infinity, which is pi over 2. So this one you get our pi over 2 because this arctan infinity. So 1 over 2 times pi over 2. Let me factor out the 1 over 2 here. So you can get pi over 2. Then this one, 1 minus 1 is 0. 2 over 2 is 1. Inverse tangent of 1, which is this one, you are going to get pi over 4. So you are going to get pi over 4 here. So let me just add up the coefficients of pi here. 1 over 2 plus 1 over 4 times 1 over 2. So you can get 3 pi over a here. Therefore, inverse tangent of square root of 2 plus 1 is equal to 3 pi over a. So we can put it here. This is equal to 3 pi over a. And then, since we factor out the square root of 2, so we are going to write what is the value of inverse tangent 1. Inverse tangent 1, which is pi over 4 here. So we are going to subtract the coefficients of pi here. So 3 over a minus 1 over 4, which is pi over, you get pi over a. So you can get square root of 2 times pi over a. So the result of this integral is equal to square root of 2 times pi over a. So put down a result, which is square root of 2 times pi over a. Right? Square root of 2 pi over a. And you can see this square root of 2 and this square root of 2, they cancel each other out. So ladies and gentlemen, this integral result is pi times pi, which is pi squared over a. A really beautiful result like that. So here is our videos, and stay tuned for more qualities integral videos. Bye bye.